Okay, here we are on page 2. This is actually a newly refilmed page 2, so it might not jibe with the other two sections perfectly, but it is better and more clear than the last version of this, which I'm deleting. Anyway, if you're adding these two vectors, I'm telling you that these are vectors, so this is clearly in rectangular form. There's no degree symbol. This is not polar. It's just good old simple rectangular. You add the x's. 5 and 8 is 13, add the y's, 7 and negative 3 is 4. We just answer in the same format as the question. In this case, it's rectangular. All right. So this one, however, these guys are polar because of the degree sign. All right. We never put bearing in this format. All right. So in polar, I'm going to sketch this one first, and it's rotating up like we did in the last page, 70 degrees at a length of 5. It's a vector, so it's an arrow. This is 8, and it's all the way around 10 degrees past. That's just 10 degrees past 270. That's a right angle. And we get these vectors. 5 is shorter than 8. When I sketch my parallelogram, this is my approximation of that resultant vector. But I'm going to do the math. It's all about the numbers. So I do the r cosine r sine formula. I plug in those numbers, 5 cosine 70, 5 sine 70, here in rectangular form, right? These guys now are in rectangular form. I can add them then, just like I did in this problem up here. So when I add them, I've added the x's. When I add them, I add the y. I get negative 3, positive 3 for the x's. So that makes sense. I'm going over about 3 and down about 3 to get this, okay? Then the math of it is that you convert backwards. This is converting from rectangular to polar, and I square each of them. I add them up. I square root that, so that length is 4.43. When you square a negative, it just becomes positive. Then when I go to find the angle, what I'm always going to do is find this alpha. That's called the reference angle. It's made with the horizontal. So I do tan to the minus 1 of the y value. That's 318. In a triangle that I'm drawing, it's never going to be negative, so I just drop it off. I just do the absolute value of those. Drop off the negative, and then that's always over the x. Always tan to the minus 1 of the y value over the x value. And I get 45 degrees, 0.73. So that's very close to 45 degrees. So then the polar angle is all the way around 360, less that 45 degrees, so I subtract it and I get 314. So there's the answer in polar form. Okay, moving right along then. I've got triangles here I'm going to solve. We have to diagnose what these are. This is an angle, and this is an angle, and this is a side, so that should be pretty easy. Angle, angle, side is always law of sines. So I'm just going to start by sketching this with my skinnier angle here. That's about 23 degrees. Half of 45 is 23 degrees. That's angle A. And then angle B is going to be 87, so it's close to 90. I'm just going to tilt it in a little bit to show that it's not 90. And if this is 87 degrees, then this is going to hit up here, and 87 is B, so this is angle C. I do the math. 3 and 7 is 10, so that's 90, 110 degrees, so this is 70 degrees then right there. Okay? Once I've found that, I'm going to angle, the measure of angle C. You don't need to use the little m's. We don't use this anymore. It's kind of an old way of writing it. Is 70 degrees, but I need to find these lengths. If I know that C down here is 15, I'm going to solve for the smallest length first. It's just a good habit to be in. So this is length A. So I'm going to do, my unknown is on the top, A is on the top. Underneath it is then the sine of its opposite angle, 23 degrees. And that's going to be equal to the pair that I do know, and I'm going to use 70 and 15. So 15 is the side, and that goes over the sine of 70 degrees. Okay? So I'm just going to do that on my calculator super fast. I will clear that out, and I will then type in 15 divided by sine of 70. Always check to see the mode I'm in. I'm in degree mode. And then I'm going to do that, and I'm going to multiply that by the sine of 23. If you put the unknown in the top, you can just simply do the multiplication. It's a little bit easier. times sine of 23, and I get 6.23. I'll round it to 6.24. So A equals 6.24, and then this is not a right triangle, so I can't do Pythagoras. I'm just going to call that B, and then I'm going to do the same thing, but I'm going to say B over the sine of 87 is equal to then 15 over the sine of 70. Use your original data. It's a little bit more accurate if you're rounding. So I do the same exact type of thing. 15 divided by sine of 70, and then times that by sine of 87. And I get 15.94. So that's what B is. Okay, so those are the three missing parts. You're going to be given 3 and asked to find 3. So this one here, I've got a little bit of extra space. I'm going to do this one up above. This is a side, side, side. So for side, 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 we are of course going to use law of cosines. I'm going to sketch this with the longest side down. So sketch it with 20 right there, and then I'll make it like 15 and 11 for an approximation. And I'm going to solve. If this is C, this is big C. If that's 15, this is big B. And 20 is A, so that's up there. I'm going to start with the smallest angle. So I'm going to write 11 squared is equal to 20 squared plus 15 squared minus 2 times, and I just always make little bracket spots for them so I won't forget them, cosine then of the angle C. I don't know what angle C is, but I'm going to find it. And this is then always this number 20 and this number 15, and so I'm going to start doing the math. That's 121, that's 400, that's 225, and then 2 times 15 is 30, 30 times 20 is 600, cosine of C. Alright, well this is just 625, so I'm going to subtract that from both sides. So 121 minus 625 is going to be equal to then negative, that's a negative 600 cosine of C. Alright, so I can now do the math on the calculator here. If I do 121 minus 625, and then I divide that by negative 600, I get the decimal. Well, that's what the cosine of C is. So I'm going to do second cosine and then 0.84. So I can just do second answer, and I will get that that is angle C is approximately, not exactly, 32.86 degrees. Okay? So if this is 32.86 degrees, I'm going to use the law of sines to find the next smallest angle, which is B. So I'll do sine of B over its opposite side, 15, is going to be the sine of the angle I just found, 32.86, over its opposite side, 11, and I solve it. Now I put the unknown in the top, just makes it easier, but remember if I'm looking for an angle I've got to do the inverse sine. Okay, so I'm going to do sine of second answer. It's going to take that angle 32 and put it in there, and then divide it by 11 and get an answer, and then multiply it by 15, and that's my decimal, that is my sine of B. So I then do sine to the minus 1 of that, and second sine, and then I do second answer again. That's a handy little trick, and I get 47. Okay, so when I solve this, I'll do sine to the minus 1 of, I'll do the decimal, 0.739, and that's approximately 47.72 degrees. So now I know that this is 47.72, and I can take and add that plus 32.86 86. You can see how you save yourself typing a lot of stuff in. Well, if that's 80 degrees, 80.58 out of 180, I know that I can just subtract this from 180 and drop off the negative sign. 99.42, we'll round it. That's going to be 99.42 degrees. Okay, and that is then, so angle, that was angle B, is equal to, so angle A then is equal to 99.42 degrees. Okay, so there are your 3 angles to match up with your 3 sides there. Okay, and then that is it. We are good.